So this is, so I will tell you the steps also. First thing is I have Oracle virtual box. Oracle virtual box, install Oracle virtual box. Again, if you are a basic user, just now we are starting. Contiki can be used in two ways. One is the VM virtual image they are giving. In the website, you can download it directly, 2.2 GB. If possible, I can give you one. I have it. In my pendrive it is there, so you can copy. 2.2 GB you can copy, unzip it, and then you can simply use using virtual box. This is one method. Second method is download the OS into the existing Linux machine. If you have a Linux OS, you configure Contiki for it. But the main issue is Contiki needs so many libraries. You should be capable of downloading all the libraries. Sometimes you may fail, some applications may not run because it might need some special libraries that you would not have installed. So you have to find out what are the libraries available, everything you have to download and use it. As a basic user, go for this method rather than going for a complete installation. Once you are accustomed to, then you can go for trying out with your own operating system. This method, the main problem is your speed. Because it is on a virtual machine, it will be seems to be slow. Okay, but anyway, for you to show, I just brought here Contiki 2.7 and Contiki 3.0. So there are two versions available, 2.7 and 3.0. 2.7 is so common. So 2.7 is so common. So this is the front end screen. So the username password, maybe I'll just open it and show you. Okay. So install Oracle virtual box, use the instant contiki.zip, unzip it in a folder and open the VM using virtual box. It's very simple. Maybe in this OS what I have done is, I'll show you where I have done it. The downloads. You can see there's instant Contiki. You can see there's a folder, instant Contiki. When you open this, this is the file. So when you use a zip file, when you unzip it, you'll get like this. So open Oracle virtual box. Maybe I'll just show you that also. I'll try. Anyway, I'll show you at the end so that I delete them and I will do refresh. Okay. So this is my thing. So Contiki comes with two OS, Contiki 2.7 and Contiki 3.0. It comes with two versions. So if you want to have latest sensors and other devices, 3.0 have latest 3. But 2.7 it just 5 years old. But still 2.7 have powerful interface, powerful everything. I mean it's good. 2.7 is fine. So 3.0 still there are so many bugs are there, but 2.7 is almost bug free. Okay, so I use 2.7 here. Yes, I name it as 2.7 here. Okay, so now what I do is, these are the three things available here: terminal, Cooja, and Wireshark. So Cooja is the framework and Contiki is the OS. Cooja runs similar like Eclipse. So you know Eclipse, right? For Java programming. The same look and feel you will have in for Cooja also. So Cooja is the similar. Okay. So now first example I will run it. It seems to be easy, but you can explore so many things. So this is Cooja interface. Double click. For the beginner, you can double click simply. So this is my simulation window. Okay, so I can see file, new simulation, open simulation, and simulation reload. To run the simulation, modes. Modes means the sensor nodes. I'll show you what are the thing it contains. And tools. These are the tools to go for a real-time behavior performance. You can find the real-time behavior of a sensor node. And settings. Anything you want to set in this tool, the settings. So first thing I go for a simulation, new simulation. So it's my simulation. Let me go with Hello World. I have my own name. And radio medium. If you are working on the radio model of IoT, you can think about this radio medium. Else, if your work is not on the radio, then leave the defaults. Let it be. Okay. So there are different. See that unit disk graph medium UDGM, UDGM constant loss, directed graph radio medium, no radio traffic, multipath ray tracer medium. These are the different radio models available in Contiki. Suppose you have a device, your simulation, which model you want to go for. Distance loss means what? Distance loss. You understand what I was telling him? I was telling him something. You understand? No. Distance loss. When the distance increases, the communication is the first radio medium. Am I right? Yes. Hello. Can you listen to me? Everyone understands. Constant loss. Second model. Suppose your sensor is on which radio model, accordingly you can select it. If you are not bothering about radio, leave it. That's one of the project done by our student. What he did is same simulation, he repeated 5 times for 5 radios. Compare all the 5 radios for the optimum performance of the mode. It's a simple undergraduate project you can give. So I am just leaving as it is. And mode startup delay milliseconds. So 1 second mode startup delay, because the mode will take some time to start. And random seed. Seed again, this is so many people they don't bother about the random seed. But the random seed is very powerful. One example I am telling you. You have a sound like songs in your phone. You listen to songs. Right? Now I have 10 songs in my playlist. Song number 3. I am playing song number 3. Next, I put in shuffling mode. Shuffling mode means usually I don't want to listen this song next. Let it be shuffling. Song number 3 I am playing. Next thing is I want to play. Automatically the song will be coming song 5, for example. Song 5. Previously I listened to song 2. So 2, 3, 5. This is the cycle. Now I am in 3. When I press previous, what song will go? Which song will go? Why can't it, since it is shuffling, random, why can't it go to some other song? You understand what I am telling? You already listened to song 2. Now you are listening to song 3. It is in shuffling mode. It is in song 3. Now again you press back. You are telling it is going to song 2. Why can't it go to some other song? Because it is a shuffling mode. It can go, right? There is a difference in that. If you again go back to song 2, the random seed is 1. It could be random, but the same cycle of operation, whatever happened, the same cycle it works, because algorithm works this way. But other than value number 1, it is completely random. If we click back to the previous song, it never be 2. It can be any song. So similarly here, random seed, the random seed determines the random behavior of a node here. Anyway, let us not go deep into this. So I create a hello world simulation, create. Now I got how many windows? 1, 2, 3, 4, 5 windows totally. So this is my first window where I am going to create a network. My run speed limit. So here only I am going to do all my simulations, start, stop, pause, reload, everything. This is my nodes. If I want to write any nodes for further usage, I can use this. And mode output, the output of a sensor node here. This I am going to use it here. And timeline, what happened at what time, how the packets are lost, everything I want to see it here. Okay, so first thing what I do is view. You go to view, addresses, I enable most of the things. Log output, printf, LEDs, radio traffic, positions, 10 meter background grid, type of the mode attributes, and radio environment. So everything I have just created here. Now I go to modes, add modes. In this add mode, create a mode type, new mode type. You can see that these many modes are supported in Contiki. Disturber mode, import Java mode. First thing you leave it. Third, Mica Z, ETH 1120, TREXEP 1120, TRXEP EXP 2420. There are so many modes available. You can see there are so many modes. So let me go to mode, sky mode. I go to sky mode here. Click this. Description of the mode. Now firmware, Contiki process or firmware. What firmware you are going to use on the mode? Firmware means what? My code. I have written a code. I want to download the code into my sensor node. So which code you want to use it? So I browse it here and go with. See, I have written a code. Pradeep Kumar. See, my own folder. I have written a code. My first.c. I will show you that. Afterwards, I will show you. I will go with hello world. Hello world. So hello world.c. This is my hello world. Open. So once you open, you can see this here. A command make hello world.sky target equal to sky. That means I written it here. It is now targeting for sky mode. I don't have a sky mode, but still I can able to run on a sky mode without having any device. If you have a device, it will be on real. If you do not have a device, it is on emulation. Okay. So then compile. So you have to compile. So once you compile, you get it. But here only you will get sometimes a problem. If your coding is missing something or some libraries are missing, you get an error here. Once you get an error, you cannot create any node unless you clear the error. Okay. So now nothing happens here. So create. So create. So create it. How many modes you want? So let me use 10 modes. You want random positioning, linear, ellipse, or manual. So accordingly, if it is random, it will be random. So let me use ellipse. Let's say I check it. I never tried it. Elliptical. So all the nodes are completely circular or elliptical. Okay. So you can see that there are something is shown here. 34.5, 2.44, 65.45, 2.4, 20.61. So X and Y locations are shown. And near to there you can see 3 LEDs are shown. Red, yellow and red, green and blue. Red, green, blue. LEDs are also shown there. And 0.0 there are something is shown here. We will see what is that. Okay. So now my nodes are ready. It is a hello world nodes on a platform. So I can able to give a start. Once I am starting, you can see all the sensor nodes print hello world because it is programmed for printing hello world. It's a simple application. It's programmed for that only. And you can see that the mode output, what is happening in the mode, you can see this. So rhyme started with address 8.0, that is a mode number 8. This is mode number 2. Starting hello world process, it prints hello world. So CSMA, Contiki Mac, channel check, rate 8 Hz, radio channel number 26, and node ID is set to 8, and MAC address, this is a MAC address, and Contiki 2.7 start. So this is for node number 8. Like that, the simulation goes like this. This is the output of the mode. And here this is the timing. This is the timeline. So based on this timeline also, you can see radio channel. You can enable radio channel. You can enable log output. You can enable watch points. And you can enable modes also. So all the 10 modes it shows. And you can save to file and print statistics to console. This timeline you can able to do that. But actually this is only a hello world, so it is not showing much. But sometimes it shows with various coloring packets. Red color, yellow color, green, blue, like that. If packet is being dropped, it will show a packet drop in blue color. If packet is lost, it will show in red color. So you can able to count the number of packets, how many packets have been lost, how many packets have been dropped. So many things you can able to predict in this timeline. I think possibly by tomorrow, maybe they may be showing you how really thing works. Okay, so this is a basic application where how can I use this device. device. Okay. Now, for example, if I want to see the mode, right click, see that. Now we can click this here. What do you mean by this? There are two circles. So in my screen it is green and grey. There it is yellow and grey. So what do you mean by this? Why these two circles? Any guess? Node 1, 10 and 9. They are in? There is a range. They are in which range? Dash range. No, dash range. Transmission range. Good. For node number 1, 3 and 2 are in 3, 2, 4, 5, 6. They are in interference range. So you have transmission distance and interference distance. Okay, so this circle, this is UDGM, unit disk graph medium. So that means it has whoever there in the green color medium, they are in transmission range. They are outside this, they are in interference range. Okay, so most of the time, even they are in interference, they could not get the packets if they want to send. Suppose the node 10, I am referring to node 10 now. Node 10's radio medium is this. So if a node 10 want to send a data to node number 3, it can be possible. How? 1, 2 and 3. Because for node 10 it is interference, but for node number 1, it could be in transmission range. We will show you that. Actually in RPL protocol and QAP you can able to see the difference. See now for node number 1, 2 is in the range. And for node number 2, 3 is in the transmission range. So automatically your packet from 10 will be going to node number 2, irrespective of the interference of transmission, because of the path. What it has. So even when your system is running, suppose I am running the system, suppose if it is transmitting, still it is running. So I can simply move the nodes here and there like this to adjust it when they are transmitting packets. But now there is no transmission going on, but there is a chance that we can able to do that. Okay. So this is a simple hello world application. This is a simple hello world application. Okay. So and even I can show the nodes also. Right click. Mode type. Okay. So there is one thing on collect view. So what you do is take any node, right click, and here mode information, we have mode information. So this is the mode information, sky mode, mode interface viewer. So you can able to see the all information about the mode, position, prime address, IP address, mode to mode relations, mode attribute, cycle clock, button, all these things you can able to see here, and even the radio also. So this is IEEE 802.15.4 radio. So it shows you what is the signal strength. So current channel is channel number 26. So this information you can able to see. And if you go to tools, mode types, this is the real hardware of a sky mode. This is the real hardware. This is how it looks like. So this is the sky mode. How the mode looks like, this is the sky mode. So that means everything you can able to see. They have a complete cross compiler available for a corresponding mode. Okay. So now I close this window. If you want to save the simulation, you can save it, else no need. Okay. So now what I do is I go inside the folder where really the thing happens. Okay. So in the home folder we have Contiki 2.7. So I am going inside Contiki 2.7. In this we have a folder called as examples. In the examples you can see all these source code. Suppose I want to go with IP version 6. One example I am showing you. IP version 6. Here IP version 6. So in the IP version 6, you can go inside. You can see that RPL border router, RPL collect, RPL UDP, simple UDP RPL, and sleep radio, sky versions. So if you see RPL border router, so you can see the coding of border router. How a border router really works. So border routers are very powerful in IoT applications. See, one example is I have internet connectivity in this room. For example, there could be a router, right? I don't know whether it's a router or not. Yeah, it's a router, right? It's a router. So when I check my Wi-Fi, it is displaying so many Wi-Fi signals. In my phone, so many Wi-Fi signals are being displayed. So that means I have a router here. Similarly, for the IoT devices, most of the IoT devices they do not have access to the outside environment. They have to contact via somebody else. That somebody is nothing but border router. That somebody is nothing but a border router. So, if you want to know how really a border router is implemented, this is the code. This is the code. So, static UIP, IP address, prefix set, border router process. So, this is how the way the coding has been written there. So, if you are working on this Contiki OS, so you have the source codes available in the examples folder. Almost whatever you need for IoT, everything is available. Only thing is, if you want to modify something, modify it and then compile it again. I will show you that how that you can able to do. Okay. So now what I do is I have written a example folder here. Pradeep Kumar. Yes, I created a folder here. See that I created two files. My first.native and my first.sky. Okay. So I didn't create all the folders. I delete what are things I didn't create. So these folders I didn't create. I'll create again. Move to trash. And my first native I will delete. And the symbol tables I will delete. My first.sky also I delete. These are the three files I have written. Only three files I have written. Okay. So first file I have written is my first.c. It is like hash include contiki.h. So please see that this is a very basic thing of Contiki. Double quotes and here it is this. Why this difference? Oh, it's a smart code. Okay. This is double quotes for the header file is part of the library. Here this is for globally it is defined. So all the standard header files we have to use within square brackets. Our library header file we have to use in double quotes. This is a regular standard what we follow. There is no main function here because of protothreads. Contiki uses protothreads, so no main function. No main function. So any C program starts with main function, but here there is no main function. So my function always starts with the process command. So it's a name of a process. What is the name of a process? My first app. And I define a name called as my space first. So my name of my process and what is the address and what is the variable name I am going to use. So what I do is MIT app. I use it. I create like this MIT app and auto start processes. So when I run the simulation, who has to auto start? That means the kernel has to start a process when it first time it is running. So I need to specify what is to be auto started. So my same app I can auto start here. So ampersand this thing. Ampersand MIT app. So what is an ampersand is for address location. Because we are specifying that you start this app when the kernel is being started. Okay. Then process thread. Process underscore thread. So process thread means it is a proto-thread application, no stack, nothing. Stack is not there, but it needs some data, it needs some environment there. So my MIT app, comma, EV, environmental variables, all the environment you supply, and the data whatever it needs, it can be getting from the process, parent process, without any stack implementation. Now, this keyword I can use static int, maybe I use static also, static int I am fine with Contiki, %d, comma I. Okay, so %d, comma I means the I will be displayed here. If I use I++, let me try it. I didn't use, so static and printf. So process, anything, whatever you do, you start and end with process begin and process end. Process begin and process. This is the nomenclature for any files in Contiki OS. Maybe I'll show you another file somewhere in the other examples. UDP, I'll go with UDP. UDP IP version 6. UDP client. So this is a UDP client in IP version 6. You can see process UDP underscore client underscore process and the name of the process auto start. So resolve process UDP client process. So two processes have been auto started when you go for UDP. Then the name of the functions. Finally, at the end you will have the process thread. See process thread, UDP client process, EV data, static stub E timer, process begin, printf and set global address. At the end you will have process end, process yield. So there are at the end you have process end. So whatever you write, anything you can write between the begin and the end. Okay. So this is UDP client. Now I have written this printf. I am fine with Contiki %d I++. Anyway, I am trying it now. But the reason is again when you do the programming, I use static int. You know why I use static? There's a reason for it. If you simply give int I equal to 100, it is not an error, but maybe I think it shows error. I suppose. So if I use function 1, so if I use static int I equals 0 and integer I equal to 100 or 0 something. So suppose we use I equal 100, I equal 0 means, so this is local variable, this is global variable. But when I use static here, this is also global variable. Or before creating any process, I am going to use a variable name. That variable name you have to have static so that it will be referencing from the RAM, not from the local stack or not from anywhere else. So it will directly fetch the value from the RAM. Moreover, the reason is the process thread are protothreads. Protothread doesn't use any stack. So there is no stack available. So everything variable have to be referred in the global memory. That is the reason why I use static here. So once it is done, after that you create a makefile. Please see the name of the makefile. It should be capital M AKEFILE. The name of the file is myfirst.c. Please remember its name is myfirst.c. So this is a syntax for makefile. Contiki underscore project equals myfirst. The name of the file without any extension. The name of the file without any extension. myfirst. Then all. So compile everything, a colon and $Contiki project. So that means you have to compile everything for this. Suppose I have two files, my second. Suppose I have another file. I can use second file. Like that I can able to write all the files. See, in my application I can have only one C file, or there will be sometimes I have more than 2 or 3 source code files, .c files. I want to include everything means I can include it. But header files are exempted. You need not write header files, .h. .h you need not write it here, only .c files you can refer it here. So in my case I have only one file, so I use this myfirst. And UIP conf IP version 6 equal to 1. Hashing. What is hashing? I am commenting it. So that means as of now the configuration for IP version 6 is 1, but I am hiding it. I am commenting it now. Whenever I want to enable IP version 6, I can able to do that. I can remove this and I can enable IP version 6. Okay. So it is only to give a warning that I am not using IP version 6 as of now. But if you want to enable it, you can remove this and then you can recompile it. Okay. And Contiki equal to .. What do you mean by this? Any idea? Because I am just making you to remember. Tomorrow there is a hands-on session for you. So that time you can remember all these things. .. Yes, changing the good, changing the directory. So I will tell you that. So for example, I go to terminal. Okay, so ls Contiki -2.7 clear. So I am going inside examples, cd examples ls. Okay. Now I am in Rajit Kumar. Please see that I am in this folder now. I am in this folder. So What is the home folder for this? Contiki 2.7. This is the base folder of the Contiki OS. Okay. I need to, how many directories I need to come back? 2 directories. So for coming back, cd space dot dot slash dot dot. When you type it, okay, first I will show you this. PWD. What is PWD? Present working directory. It will show you in which directory I am currently working. I am working in home user Contiki examples Pradeep Kumar. Okay. Now I am using cd space dot dot slash dot dot. Put enter. Now I use PWD. Now in which folder I am in? 2.7. So in the make file, we are telling that the base folder is two folders before it. So when you are seeing for the first time, you definitely get a confusion. Why there is a dot dot slash dot dot? And this is the reason. I am going 2 folders. Previous 2 folders I am just going. And include $Contiki. That means this Contiki slash makefile.include. So that means there is a file called as makefile.include in this folder. Include that also. When you go for a compilation, include that also. Fine. So that is the reason it is given. Okay. This is the second file I have written. This is the second file. Third file, makefile.target. What I have written? Target equal to sky. So I don't have anything else. So I want to use a sky mode. So I use target equal to sky. Okay. So 3 files I have written and created in a folder called as examples Pradeep Kumar. I have created. Okay. Now I go to the folder. CD examples, CD Pradeep Kumar. Now see that my folders are there. Makefile target, these are all temporary files. Whenever I save it, it creates a temporary file. So if you want to remove it, you can remove. Okay, fine. Okay, let it be. Now when I want to compile it, my command is make. Command is simply make. See now it is running. Okay. So now if you do not get any error, it's fine. But if you get an error, you have to solve it. Maybe I'll make an error here. So what I do is, somewhere I remove the semicolon. In the 100 I remove the semicolon, I type it make again. It shows me error. See that? My first.c function process thread my await error expected comma or semicolon before get open. So it will throw an error like this. So you have to correct the error. So make done. Now it is done. No errors. Now see the list of files. How many files are created? See that. First time when we are creating this file was created, these 4 files and target file 1, 2, 3, 4, 5, 6. We have already done it. But now Contiki-sky.a, Contiki-sky.map, my first.sky, obj_sky, symbols.c, symbols.h. So these files have been created here. So these many files are created. Now I didn't have native target. So what I do is make target equals native. Simply make target equal to native. I am running it now. Yes. Now I see this. No errors here also now. Now you can see my first.native, my first.sky, and there is a Contiki native.a and native for map. What is the map? Is memory map. Map is memory map. How I am going to refer my memory. So that's what here Contiki-native.map. A for assembler directives. Assembler directives, because most of the things are in the hardware directly deals with assembly languages. So it's assembler directives. Maybe you can open some file cat Contiki-native.a. See, this is a file what was created. Okay, so now I want to run my native file. I want to run my native file. What I do is dot slash my first dot native. So to run this file. Now you can see Contiki 2.1 started. Rhyme started with address 2.1. Mac, null Mac, RTC, null RTC, network rhyme. I am fine with Contiki 100. I was printing a printf statement there. I is 100 and it was showing the value 100 here. Fine. So this is I am running on a native. Native means in my own Linux machine I am showing it. But how it happens on a Sky? So run my first dot Sky. So it shows cannot execute binary file. Why? Because this file is accepted only by Sky mode. This file can be accepted only by Sky mode. Do you get it what I am telling now? I use Sky mode and native. Two things I have done it. Native I can directly run it somewhere because I have my own machine, it is native. I am running it. Sky means I need a Sky mode for running this application. I do not have a Sky mode. Then what can I do? Now I will come to the next thing. Open Cooja. Okay, now I will come to this. Open Cooja. Then file new simulation. So my application is my first MIT app. Again create. So view, this time I only printf only I will use it, and radio traffic, radio environment and radio traffic. Other thing I don't want. Modes, go to the modes, create mode, Sky mode, browse. Now what I do is I go to examples, I go to my phone, my own folder, my own application, Pradeep Kumar. I use my first dot C. Like how I selected hello world, I am using my first dot C. Open it. Now see that my first dot Sky target equal to Sky because my node what I selected is belonging to Sky mode. Okay. So then compile it. So no errors. So I can create it. Create. Let's say I use 10 nodes. Again I go with random positioning. I'll go 10 nodes on a random position. Okay. So now next is I run it. Starting MIT. So that means now my own application running on a Sky mode. So you do not need a Sky mode for running this application. You can directly use a Sky mode for this. Fine. So this is a very simple application wherein you can able to explore how really Contiki OS works. How can I create a new application? Okay. So do you need to explain, do you need to write it or you remember everything? So tomorrow when you try how to create an application in Contiki. So how to create an app in Contiki. So first step is create a folder inside Contiki -2.7/examples. Create a file, C file with a name, any name you can have, but please don't give this file name like this, my first.c. Don't give like this. Your file name should be single syllable word. It should not have any blank space in between. Okay, so either it can be my first or like this you can give, or like this you can give. So best method is like this, my first, M capital letters, I O small or something. My first.c and give the paste the source code here. We will copy this here. Okay. The third is create a file called makefile and give the paste the code. given below. For create another file, make file.target and type the following line. Target equals sky. So below that I give like this, so my first dot c and make file. So make file is case sensitive as well as it is space sensitive. So space and case you have to take care, else make file will not compile. So hash make file. Okay, I use like this. Maybe I will share this file also. So that how to Contiki OS. So your first step in Contiki begins here. Any first step begins with a small step. Though it code will be very small, but you can understand so many things on these lines. Okay, create a folder inside this and create a C file with the name my_first.net. Paste the source code as given below. So below I have given. Create a file called makefile and paste the code given below. That's also given below. Create another file, makefile.target and type the following line. Target equals sky or whichever target. So whichever target you want, you can able to do. And there is one more command here. Make upload. See, so if you are uploading your file to the real sensor mode, your concept is like this: make my first dot upload. So please remember. So this I have showed you. Make target equal to sky, save target. That is, this target will be saved. And if you want to upload from the terminal, if you want to upload to your, suppose you have connected your hardware to your machine, your sky mode to the machine, then you can do the next step like this: make my first dot upload. After that, make login. That means you are logging to the sensor mode directly at this time. So this also you can try in terminal mode. No, that's what the sky code comes with Contiki with your code. Both together it becomes one single code. That code if you upload, Contiki OS also will be within it. So we can check the size of the file. I'll show the size of the my first.sky. So you can see the size here, 58.1 kilobytes. So you can see that my first.sky is having 58.1 kilobytes. But 32 kilobytes, if your space is there in your mode, this file will not be uploaded because no space available. At least you should have 64 kilobytes. And native file you can see 153.9 kilobytes native. Because native is running under Linux, it doesn't need that many things, so it have any size, no issues. But Sky you have this thing. Maybe I'll try with Mica also. I try that also. Maybe I'll try that. Make target equal to Mica Z. Yes. Mica Z is a very basic node which was available a long back. Okay, so now I use ls. So I have another thing also, my first dot Mica. So if you see the size, see that 193 kilobytes. So Mica Z again have still more huge size. So your mode doesn't support it. That's why when you have Mica Z modes, the Mica Z mode doesn't support because it doesn't come beyond 16 kilobytes of space. So that is the main issue here in Contiki OS. So Mica Z doesn't support. Okay, so this are about this. So the command is alone. So you are running using commands without using the GUI, here are the commands. So go to terminal, go to your folder. So in my case it's Contiki -2.7 examples this one. Make target equal to sky, then make my first target equal to sky, my dot c, sorry, no need. First dot upload. Sometimes definition you can use sudo make login, sudo make my first dot upload. So sometimes the permission denied, the permission may be denied. So you can use sudo make my first dot upload. I use a dollar prompt here. So this is the terminal. Yeah. We'll try this. Make my first dot upload. Okay, I think it's uploaded. You can see that there is a file called as object sky is created. So inside that you will see object file would have been created. Then make login. So permission denied because the data is not accessible for all users. So we have to use sudo. Password is user. Okay. So now I get an error called as input output error because the device is not connected. I get an error input output error. So sudo make login. So sometimes you can use the sudo command. So using save target sky, make msp430-gcc. This is the library you need to install on Contiki. But if you use instant Contiki, everything comes by default. And this device TTY-S0 is the USB device that you are connecting the mode into your machine. So input output error, it is not connected, so that's why you get an error like this. Else you can directly log into your sky mode. You can run your sky mode from the terminal. So this is the application how we can use Contiki OS for. And one suggestion here is, now I have examples here. Everywhere I have examples. So one example I just show you. Email example. Then FTP, IP version 6. Then ping IP version 6. New IP version 6. So mostly we have source code for everything. And web server UDP IP version 6. Web server here, web server IP version 6. So I'll take IP version 6. RPL. I'll show you one example on this. Maybe I will not discuss in detail about it. I'll just show you an example here. So how data transfer is happening in Contiki. Just to show you, because the hello world just display hello world, you cannot get much information. So new simulation, I use my simulation here. Go to the modes, add modes, I always prefer sky mode, but whenever you want to prefer the other mode, you can use WIS mode also, WAS mode. This is also available in the market. WIS mode and sky modes, they are still available in the market. If you want, you can purchase also. So I prefer sky mode. Then what I do is, I go to the folder IPv 6, then simple UDP RPL, broadcast example. So broadcast example, compile. Create. So let me use some 5 nodes. So 5 nodes, I use IP addresses, then I use radio environment, I use radio traffic. You can see what is this? See, this is a broadcast example. So how the nodes broadcast themselves. So you can see that there will be some yellow packets, green, yellow, blue. There are some green packets also moving. Okay, so this is how the broadcasting works here. And what do you know about these addresses? Have you seen these addresses? FE80, FE80, then 212, 7402, then 2:202. What could be this? This IPv6. IPv6 have how many bits? 128. Okay, now can you count how many bits? FE80, 1, 2, 3, 4, 16 bits. 212, that is 0 to 12, again 16, 1, 2, 3, 4, 5 16s, how much? Where are the remaining? Yes, so double colons, whenever you have a double colon here, in between you have all zeros for mapping entire 128 bits. Suppose if you want to see this address, you can use coap colon / this way. You have to run it. So HTTP, how do we run? HTTP usually we run this HTTP / FE80 like that we will run. But here for coap means constrained application protocol colon / within square bracket you have to run the IP inside the browser. So this is one simple broadcasting application that uses the data like this. So you can able to move the nodes also, and you can see that whether they are in range or not. So now I click this node. See, node 3 is getting. Now I'll check it. Now see whether node 3 is getting any packets. No, because they are not in the interference or transmission range. Okay, so this example on. So again you can see this timeline. Actually, there's a blue color thing and events, radio channel, log output, and watch. So save to file. You can save to file. Some file I can name the file as file and save it in the user. Now we just go and see the folder. Okay, see this is the file what I have saved, the timeline. Sky 1, this time mode Sky 1 says sending broadcast. Then this node, data received on port number 1234 from port. So this textual thing is, you can see this is radio channel number 26. So like this, your data will be written by the software, and you can predict also. So how many packet loss, how many packet drops, everything you can predict. And this thing, the complete mode output from the mode. First, for a few lines for setting up the mode, and the other lines are for data received from the mode. And there is one more thing. Maybe I don't know whether anybody will tell you about that or not. So we'll say there's a Java based tool called as collect view. This is one of the powerful thing in Contiki OS. I don't know whether anybody show you or not. Anyway, just give a glimpse of it. There's something like collect view. You can see there's a new window opens. So this is the sensor data collect. So means that I have a sensor. I want to collect the data. Either you can collect from Contiki directly, or you can collect from the real sensors also. Directly you can collect it. See, node control, sensor map, network graph. So you can get the network graph also. But for the network graph, I think here. So it is collect view. Okay, I'll check it. Sky number 2. So what do I do is I click this here. Server socket. No, it is not. So in some networks you can get the power information also. Sensors, how many sensors? You get the temperature values here. The temperature you can say average temperature, battery voltage of the sky mode, and you can get the network information. So beacon interval, network hops over time, network hops per node, ETX, estimated transmission to next hop, average routing metrics next hop, latency, receipt over time. You will get a graph here. Automatically the sensor nodes will report the graphs, they will report the data, and power information, average power consumption, radio duty cycle, instantaneous power, power history, and node info. So everything will be displayed here. Actually this application doesn't suit that, but there are some applications wherein you can able to collect the data from the sensors. So program nodes, you can click this directly, the node will be programmed. When the system is, when the nodes are running, it can program. Disconnect from serial, start collect. We'll write start collect. So once you start collecting it, we'll check it. No, it is not. So in this node, it is not powered. So there are some nodes, some applications that are powered using collect view. So you can use this collect view in Contiki node. Yeah, collect view application type. So there's an application. So the last thing is collect view. Okay, collect view is one tool that prints a complete performance matrix of the network. Okay, so that's all about the basics of the operating system. There are so many things, so many other things are there. One example is I was trying this. Actually, my thesis is on IoT only, on power modeling of IoT system. I never go for an application. Rather, I went for a system inside. So what I did is I do not have any power calculation by default in Contiki. There is one thing called as power trace, and there is another thing called as energist. So the energist and power trace I modified as per my convenience, and then I calculated the power occupation of a IoT application. So this is what I have tried it. But during the time you get so many junk information. That means whatever results you see on the screen might not be suitable for your work. So once you start exploring, see, Contiki is a very big version. As if there are some applications, but when you start working on it, you get so many queries, doubts, errors, so many things. I have some videos related to Contiki in my YouTube channel. Maybe you can check also. Maybe after these 2 days, you can check a YouTube channel. So youtube.com/Pradeep Kumar. And I write about IoT also in my website nsnam.com. If you are networking, you might have seen my website. So these two, one is my channel where I have some 4 or 5 videos related to Contiki, and for RIoT also I have written something. And my NSNAM, my website, I write about network simulators and emulators. For Contiki. No, seen any manual. But they have their own documentation. In their website, they have, in Contiki website, they have their own documentation. It's not like a manual, it's kind of operating instructions. Using that, you can able to do something on it. But mostly, we have to try on our own, but there are some documents available in the web. But officially, no documentation. They have some information available in their website. Some simple things is what you can do. Thank you, friends. Any queries? No. Python is not supported. But here, if you use 6LoWPAN in NS3, you have option of Python.
So if you make changes in the protocol, and can we make the boot to run the protocol?
Yes, ma'am. That's why you can see when you change the protocol, you don't go with the GUI. Always prefer the terminal mode. What you do is do the modification in the C file. Then you come to the folder, you type make. First, because most of the folders they are given, they have some target already specified. But we are going to run on native. So first you try with native. Because native will give an output immediately. Sky, other thing, it will give the output in the GUI only. So in that case, first you try with the native. So 6LoWPAN, there are so many people have done modification in Contiki. So this easily can be done.
Like NS?
Yes. It is easier than NS2.
So you'll be giving this file?
Yes, ma'am, I'll give ma'am. Continue.
இப்போ நீங்கள் அனுப்பின ஸ்லைட் தான் எனக்கு போட்டிருக்கீங்களா?
Slide
சேஞ்சஸ் இருக்கா?
இல்லை மேம், அதே சரி. இதில் காப்பி பண்ணிட்டேன்.
ஸ்டிக் உங்களுக்கு தான்.
ஆனால் இது என்னுடைய மிஷின்.
இல்லை அது உங்கள் மிஷின் தான். நீங்கள் உங்கள் ஸ்டிக்கில் தானே போட்டீங்க.
இது காப்பி பண்ணிடுறேன்.
பவர் மாடியூல்லாம் இல்லை இல்லைங்களா? நம்ம இப்போ நீங்கள் இந்த போட்டிங்கெல்லாம் கலெக்ட்னு சொல்லிட்டு பட் அது வந்து ஒரு அப்ளிகேஷன் இவ்வளோ எனர்ஜி கன்சியூம் பண்ணணும் அதெல்லாம் வருது. பட் எப்படி மாடல் பண்ணியிருக்குன்னு பார்க்க முடியாது.
பவர் ஸ்டேஷன் இருக்கும் பாருங்க.
ட்ரேஸில் வந்து கன்சம்ஷன் மட்டும் வரும் சார்.
ஓகே.
பட் அது எப்படி கால்குலேட் பண்ணியிருக்காங்கன்னு
இருக்கு அந்த ஃபைல் இருக்கு. பை டிஃபால்ட் அது ரன் ஆகுது. பார்த்தேனே. டைமர் செட் வந்து ET கிளாக் செகண்ட் டு ஃபோர்த் ரேண்டம்.
இப்போ எல்லாமே மாற்றிக்கலாம். டிலே வந்து 10 செகண்ட்ஸ் அந்த மாதிரி.
இது எனக்கு பத்தல மேம். அதெல்லாம் நான் இன்னொரு எனர்ஜிஸ்ட் ஒன்று இருக்குது, அதுவும் நீங்கள் ட்ரை பண்ணிக்கோங்க.
எனர்ஜிஸ்ட்.cல மாற்றுமா இல்லை ஹெச்ல மாற்றுமா? டாட் ஹெச்.
ஹெச் வந்து ஒன்லி உங்களுக்கு ஃபங்க்ஷன்ஸ் மட்டும் தான் இருக்கும். சில தான் உங்களுக்கு மெயின் அல்காரிதம்.
மாற்றி நம்ம திருப்பி கம்பைல் பண்ணிக்கலாம்.
பவர் நான் எழுதுகிறேன், கீழே உங்களுக்கு எழுதுகிறேன்.
எனர்ஜிஸ்ட்.cல இனிஷியலாக நோட்ஸ் எனர்ஜி வந்து எவ்வளோங்கிறத நம்ம செட் பண்ண முடியுமா இல்லை
செட் பண்ணலாமா?
அதில் ஆக்சுவலாக ஒரு ஃபார்முலா கொடுத்துருக்காங்க. அதில் நம்ம வந்து அதை எடுத்து பார்த்து நம்ம வேரி
ஆனால்
பண்ணி பார்த்து
நீங்கள் இந்த ஹெட்டர் ஃபைலுடைய லொக்கேஷன் வந்து நீங்கள் எழுதுகிற டெஸ்ட் பண்ணுற ஃபைலில் மேலே கொடுக்கணும். இப்படி கொடுத்தா தான் உங்களுக்கு அந்த பவர்
இன்க்ளூட் ஆகும்.
அந்த ஃபங்க்ஷன் உள்ள கால் பண்ணணும். நான் இதுவும் எழுதிருக்கேன் கீழே பவர் ஜஸ்ட். ஃபோல்டரே அப்படியே கொடுத்துட்றேன் மேம். பிரதீப் குமார் அப்படியே கொடுத்துட்றேன் மேம். தெரியல கொடுத்துட்டே இருக்கேன். ஓகேங்க. ரெண்டு மேம். பிரதீப் குமார் இன்சல் கான்டிக் இந்த எடுத்துக்கோங்க.
ஸ்டிக் இதில் போட்டு நீங்கள் டெஸ்க்டாப்பில் பார்க்கலாம்.
கனெக்ட் பண்ணுறீங்களா?
Thank you, sir, for the talk. Now I request coordinator of the workshop, PT Meena, to present the speaker with the I think PS mouse. Yeah, actually.
பிரதீப் குமார் இன்னும்
இந்த கீழே இன்சல் கான்டிக்.
இந்த வேலையை